Ray's Astrophotography has just exposed something NASA conveniently left out of their press conference about Comet 3I Atlas.
What would happen if an object from another solar system, a cosmic messenger 4,600,000,000 years old, were crossing through our cosmic neighborhood at this very moment, and the world's most important space agencies had decided to omit the most extraordinary details about it? This is a story that deserves to be heard until the end, because what is about to be revealed completely changes our understanding of what it means to be visited by something that does not belong to our sun.
Good evening, dear listeners. Felipe Suarez here, accompanying you on this journey through the stars. Have you ever wondered what it feels like to look at the sky and discover something that no one else has noticed? Have you imagined that from your backyard you could capture secrets that the great telescopes prefer not to show? Because exactly that, is what a man named Ray managed to do with his amateur telescope. Are you ready to learn what really happened with Comet 3I Atlas?
The story begins on an ordinary night in the year 2025, somewhere in the United States, where city lights cannot contaminate the sky. Ray, an independent astrophotographer whose last name remains anonymous in the amateur scientific community, was pointing his telescope toward a region of the sky where he knew something extraordinary was occurring. He was not a career scientist. He did not work for any government agency. He did not receive funding from any prestigious institution. He was simply a man passionate about the cosmos, armed with equipment that, although modest compared to the great observatories, was sufficient to capture the truth. Comet 3I Atlas had been detected months before, and since then had generated moderate excitement in the astronomical community. But what Ray was about to discover that night, and the following nights, would expose a series of omissions that NASA itself had committed during its official press conference. Omissions that, to a trained eye, were difficult to ignore. Ray's telescope was not small by amateur standards, but it also did not compare with the orbital instruments that space agencies have at their disposal. However, passion has a curious way of compensating for technological limitations. Ray had developed image processing techniques that allowed him to extract details that many professionals overlooked. He removed background stars, adjusted brightness levels, and little by little, the true nature of the comet began to reveal itself before his eyes. The first thing that caught his attention was the press conference that NASA had offered weeks before. He had listened attentively to every word, had taken notes, had compared the data presented with his own observations, and something did not add up. The agency's scientists had spoken about the comet with a certain contained enthusiasm, mentioning basic data about its trajectory and composition, but had left out crucial elements that any serious astronomer would have considered worthy of mention. Ray decided it was time to speak, to share what he had found with the world.
Can you imagine the scene, dear listeners? A man alone in his backyard with a telescope that fits in the trunk of a car, discovering things that the most advanced satellites on the planet had recorded, but that no one had bothered to explain to the public. Doesn't it seem to you that there is something deeply inspiring about that? Or does it perhaps cause you some unease to think that the information is there, available, but someone decides which parts deserve to be told and which do not?
To understand the magnitude of what Ray had discovered, it is necessary to go back in time and understand where this cosmic visitor came from. Comet 3I Atlas was not an ordinary comet. In fact, the letter I in its designation said it all. It meant interstellar. This object had not been born in our solar system, had not formed in the Kuiper Belt, nor in the distant Oort cloud that surrounds our cosmic neighborhood. 3I Atlas came from another place, from another stellar system, from a protoplanetary disk that orbited a star different from our sun billions of years ago. Orbital calculations suggested that the comet had entered our solar system following a hyperbolic trajectory, descending from the upper regions of the ecliptic plane and crossing Neptune's orbit approximately in the year 2017. For 8 years, this interstellar messenger had traveled in silence through the void, getting ever closer to the heart of our planetary system. It was not until the year 2025 that terrestrial instruments finally detected it when it was already close enough to the Sun to develop the characteristic bright coma that distinguishes comets. The hyperbolic trajectory was the first clue to its strange origin. Comets born in our solar system follow elliptical orbits, closed curves that bring them back again and again to the Sun's vicinity. But 3I Atlas followed an open curve, a parabola that indicated it had come from very far away, and that once it completed its passage through our system, it would continue its journey toward infinity, never to return. This detail alone made the comet an invaluable object of study. It was only the third confirmed interstellar visitor in the history of modern astronomy, after the mysterious Oumuamua in 2017 and Comet 2I Borisov in 2019. But unlike its predecessors, 3I Atlas presented characteristics that made it especially interesting to the scientific community. When the comet reached its perihelion, the closest point to the Sun in its trajectory, something extraordinary occurred. NASA's solar observation satellites, specifically the STEREO mission, captured images showing unprecedented behavior. The comet experienced a brightness increase that defied all expectations based on the behavior of conventional comets.
And here is where the story gets truly interesting, my friends. How many times brighter do you think this comet became compared to a normal one? Double? Maybe 10 times? I'll tell you in advance that the answer is going to surprise you because we're talking about an increase of 400 times. 400 times brighter than any model predicted. And do you know what's curious? That this data was barely mentioned in passing at the official conference.
The data was truly astonishing. Typical comets, when they approach the Sun and begin to sublimate their ices, experience a brightness increase of approximately 100 times. It is a well-documented and understood phenomenon in modern astrophysics. Solar heat warms the surface of the cometary nucleus. Volatile compounds transform directly from solid to gas in the vacuum of space, and this gas carries with it dust particles that reflect sunlight, creating the characteristic luminous coma that makes comets so spectacular. But 3I Atlas did not follow the rules. Its brightness increased 400 times, 4 times more than expected for a comet of its estimated dimensions. Ray had compared this data with the records of Comet C 2020 F3 Swan, another object that had passed near the Sun in recent years, and the difference was dramatic. 3I Atlas was significantly more active, brighter, more energetic in its interaction with solar radiation. What could explain this anomalous behavior? Ray had several theories, but the most intriguing was related to the chemical composition of the comet. An object formed in another stellar system, from materials different from those that existed in the protoplanetary disk of our Sun, could contain volatile compounds in proportions completely different from those of local comets. Ices of substances that are rare in our system could be abundant in the nucleus of 3I Atlas, explaining its exaggerated reaction to solar heat. But the brightness anomaly was not the only mystery. Ray had noticed something even more puzzling when analyzing the comet's spectral data. Data that revealed information about its chemical composition based on the colors of light it emitted and reflected. The comet had experienced a chromatic transformation that defied conventional physics. It had gone from showing a reddish tone to exhibiting a bluish color, completely skipping the green region of the visible spectrum. In terms of color physics, this was extraordinarily unusual. The normal transition of an object changing temperature or composition should pass gradually through all intermediate colors, but 3I Atlas had made a spectral jump that indicated something fundamentally different in its chemical structure. Ray interpreted this chromatic jump as additional evidence that the comet contained compounds that do not exist, or are extremely rare, in objects of our solar system. We were literally observing alien chemistry, materials formed under conditions completely different from those that existed in the nebula that gave rise to our Sun and its planets.
Doesn't it seem fascinating to you, dear listeners? We're talking about an object that literally comes from another world, from another sun, from another system completely foreign to ours, and its chemistry is so different that it doesn't even behave as we would expect based on everything we know about comets. How many times in the history of humanity have we had an opportunity like this? How many generations have dreamed of studying materials from other stellar systems? And here it is, passing through our cosmic backyard.
But the surprises did not end there. Ray had been closely following the space observation missions, and he had discovered something that NASA's press conference had mentioned only in passing, almost like a footnote instead of the revolutionary finding that it really was. In March of 2025, taking advantage of a SpaceX launch, the Southwest Research Institute, a non-profit organization dedicated to space research, had put into orbit 4 satellites known collectively as the Punch mission. These small spacecraft had been originally designed to create 3-dimensional models of the solar wind, that constant flow of charged particles emanating from the sun that bathes our entire planetary system. The Punch satellites orbited Earth at an altitude of approximately 600 kilometers, high enough to escape most of Earth's atmosphere, but close enough to maintain constant communication with control stations. And during the conjunction of Comet 3I Atlas with Mars, the mission operators had made a brilliant decision to temporarily redirect the satellite's instruments to capture images of the comet alongside the red planet. The resulting images were spectacular. They showed Comet 3I Atlas as an extraordinarily bright object in the upper part of the frame, while Mars crossed the field of view below it. Due to the orientation of the satellites, designed to look toward the sun, what was visible of Mars was its dark side, the night face of the red planet. But the comet shone with an intensity that rivaled that of the planet itself. Ray had analyzed these images with the same rigor he applied to his own captures, and had reached a conclusion that deserved to be shouted from the rooftops. The comet's coma, that cloud of gas and dust surrounding the solid nucleus, had an approximate diameter of 17,000 kilometers. To put this in perspective, Earth's diameter is approximately 12,500 kilometers. The cloud of material surrounding the nucleus of 3I Atlas was larger than our own planet. We were observing a gaseous structure of truly colossal dimensions, and this fact had been practically ignored in the official communication.
Stop for a moment to think about this, friends. A cloud of gas and dust larger than the entire Earth, larger than all the continents, all the oceans, all the mountains and valleys we know. If we could fit our planet inside that coma, there would still be thousands of kilometers left over in all directions. Why do you think this fact was not the center of the press conference? Why didn't it appear in the headlines of every newspaper in the world?
Ray was asking himself the same questions, and he found no satisfactory answers. The images from the Punch satellites had been captured before NASA's press conference. They were available. They had been processed. They clearly showed the enormous scale of the object. And yet, the official presentation had opted to show a blurry image taken by the Mars Reconnaissance Orbiter, a diffuse spot that did not at all convey the magnitude of what we were witnessing. The contrast between what Ray knew existed and what NASA had chosen to show was frustrating. It was not a conspiracy in the dramatic sense of the word. There was no evidence that someone was deliberately hiding information with malicious intent. But there was a clear disconnect between the available data and the narrative that had been constructed for the general public. Ray speculated about the reasons. Perhaps the agency's communicators had decided that certain data was too technical for a general audience. Perhaps there were concerns about generating unnecessary alarm by showing an object of such dimensions approaching our planet. Perhaps it was simply an error in judgment, an editorial decision that in retrospect seemed unwise. Whatever the reason, the result was the same. The public had not received the complete picture of what 3I Atlas represented, and Ray had decided it was his responsibility to fill those gaps. The next piece of the puzzle had to do with the comet's future trajectory. After its close pass by Mars, 3I Atlas continued its journey toward the outer regions of the solar system, and its next important appointment was with the largest gas giant of all, Jupiter.
Ah, Jupiter, the guardian of the solar system, as some call it, the planet that has protected Earth for billions of years, trapping with its enormous gravity asteroids and comets that otherwise could have impacted us. Do you know how many comets have passed as close to Jupiter as 3I Atlas will? Can you imagine the gravitational forces this visitor from another stellar system will be subjected to when it approaches the king of planets?
There had been considerable confusion in the media about 3I Atlas's encounter with Jupiter. Many reporters had mentioned that the comet would enter the planet's Hill sphere, that region of space where Jupiter's gravity dominates over the Sun's gravitational influence. But as Ray correctly pointed out, this detail alone was not particularly notable. Hundreds, perhaps thousands of comets and asteroids regularly pass through Jupiter's Hill sphere. It is a common phenomenon in the dynamics of the outer solar system. What made 3I Atlas's encounter special was not simply that it would cross this gravitational boundary, but how close to the planet itself it would pass in its trajectory. Orbital calculations indicated that 3I Atlas would make an extremely close approach to Jupiter, much closer than the vast majority of comets that cross its sphere of influence. Ray had investigated historical records and found that he could count on one hand how many comets had made similar approaches to the gas giant and survived to tell the tale. When a comet passes so close to a massive planet like Jupiter, tidal forces can be devastating. The difference in gravitational attraction between the side of the comet facing the planet and the opposite side can be enough to fragment the nucleus, tearing the cosmic visitor apart into thousands of pieces. This was exactly what happened to comet Shoemaker-Levy 9 in 1994, whose fragments ended up impacting the Jovian atmosphere in one of the most dramatic astronomical spectacles of the 20th century. Would 3I Atlas survive its encounter with Jupiter? It was a question that astronomers around the world were eager to answer. If the comet managed to maintain its structural integrity, it would continue its journey toward interstellar space, taking with it all its chemical secrets toward the void between the stars. But if gravitational forces proved too intense, we might witness its destruction in real time, an event that would provide invaluable information about the composition and internal structure of an object formed in another solar system.
Do you see how every detail of this story is connected to the others? The anomalous brightness, the strange chemical composition, the enormous size of the coma, and now a potentially fatal encounter with the largest planet in our system. It's as if the universe had conspired to give us the perfect object of study, and all we have to do is observe carefully. But are we paying the attention this visitor deserves?
While the debate about NASA's official communication continued in astronomy forums and social media, Ray kept doing what he did best, observing and documenting. Night after night, when atmospheric conditions permitted, he pointed his telescope toward the region of the sky where 3I Atlas continued its cosmic dance. His image processing techniques had been refined with practice. He had developed algorithms to remove background stars from his captures, isolating only the light coming from the comet. The result was images of surprising clarity, revealing details that even some professional observatories had overlooked. One of the most intriguing observations Ray had made had to do with the shape of the cometary nucleus, or more precisely, with what the shape of the coma suggested about the underlying nucleus structure. In his processed images, the central region of the comet did not appear as a diffuse and uniform spot, as would be expected from a cloud of gas expanding symmetrically in all directions. Instead, there was a clearly defined structure, a pointed shape in what appeared to be the front part of the comet. Ray had compared his observations with images taken by the Hubble Space Telescope, and the correlation was notable. The same pointed structure appeared in both sets of data, captured by instruments separated by thousands of kilometers and orders of magnitude of difference in capability. This agreement was significant because it ruled out the possibility that the shape was an artifact of Ray's image processing or a peculiarity of his equipment. What could this pointed shape mean? There were several possibilities that astronomers considered plausible. One was that the comet's nucleus actually had an elongated shape, perhaps similar to a cigar or arrowhead, and that this geometry was manifested in the distribution of ejected gas and dust. Another possibility was that the outgassing activity was not uniform across the entire nucleus surface, but was concentrated in a particular region, creating a directional jet that gave the appearance of a pointed structure.
Here is something that seems truly poetic to me, dear listeners. A man with an amateur telescope processing images on his home computer reaches the same conclusions as one of the most sophisticated scientific instruments ever built by humanity. The Hubble, orbiting hundreds of kilometers above our heads, and Ray in his backyard, both seeing the same truth. Doesn't it seem to you that there is something deeply democratic about modern astronomy?
The democratization of astronomical observation was a topic that Ray was passionate about, and that formed the philosophical background of all his work. For centuries, the study of the cosmos had been the privilege of a few, limited to those with access to the great observatories and the resources to keep them operating. But the digital revolution had changed the rules of the game in ways that the pioneers of astronomy could never have imagined. High sensitivity CCD sensors, which once cost fortunes and were reserved for institutional use, were now available at affordable prices for serious enthusiasts. Astronomical image processing programs, originally developed for multi-million-dollar space missions, could now be downloaded free from the internet. And most importantly, the global community of amateur astronomers had created collaboration networks that allowed sharing data, techniques, and discoveries at unprecedented speed. Ray was part of this community, contributing his observations and learning from those of others. When he published his findings about 3I Atlas, he did not do so seeking personal fame or academic recognition. He did it because he believed that science worked better when information flowed freely, when multiple eyes observed the same phenomenon and compared notes. The community's response was immediate and enthusiastic. Other astrophotographers confirmed his observations about the pointed structure of the nucleus. Independent data analysts corroborated his calculations about the size of the coma. And gradually, the consensus began to form a coherent picture of what 3I Atlas really represented. But there were also critics. Some argued that Ray was exaggerating NASA's omissions, that the agency's scientists had had valid reasons for presenting the information the way they did. Others pointed out that press conferences have time limitations, and that it is impossible to cover all aspects of a complex phenomenon in a single session. And some simply distrusted any claim that came from outside the scientific establishment, no matter how well documented it was. Ray took these criticisms philosophically. He understood that skepticism was a fundamental part of the scientific process, and that his claims should be subjected to the same rigorous scrutiny as any other result. What bothered him was not that they questioned his conclusions, but that they ignored the underlying data. The images were there, the numbers were there, the physics was verifiable. Anyone with the knowledge and motivation could repeat his analyses and reach their own conclusions.
And what do you think, dear listeners? Do you believe there is a difference between deliberately hiding information and simply not emphasizing it enough? Is it the responsibility of space agencies to tell us everything they know, or do they have the right to edit and prioritize according to their criteria? These are difficult questions without simple answers, but it seems to me worth asking them, especially when we're talking about something as extraordinary as a visitor from another solar system.
While the debate continued on networks and forums, Comet 3I, Atlas continued its inexorable journey through our solar system. Each passing day brought it closer to its appointment with Jupiter, and each clear night offered terrestrial observers new opportunities to capture its image. Ray had noticed that as the comet moved away from the Sun and ventured into the colder regions of the solar system, its brightness was beginning to gradually diminish. This was expected, since cometary activity depends directly on the solar radiation that heats the nucleus. However, the rate of decrease was being carefully monitored, because any deviation from expectations could indicate internal structural changes or the release of new reserves of volatile material. What particularly intrigued Ray was the persistence of the pointed structure, even as the overall brightness diminished. If this shape were due simply to an optical effect or temporary observation conditions, one would expect it to disappear or change significantly over time. But night after night, capture after capture, the same distinctive geometry continued to appear in his images. This suggested that the shape reflected something fundamental about the nature of the object, something that persisted regardless of lighting conditions or the distance from which it was observed. It could be the actual shape of the nucleus. It could be a permanent feature of the outgassing pattern, or it could be something completely different that scientists had not yet identified. Ray knew his instruments had limitations. No matter how sophisticated his processing techniques were, there was a limit to what a modestly sized terrestrial telescope could resolve. The great space observatories had enormous advantages in terms of angular resolution, image stability, and capture capability. And the most advanced of all, the James Webb Space Telescope, with its mirror 6.5 meters in diameter, could potentially reveal details that no other current instrument was capable of seeing.
But here comes the catch, friends. Not even the James Webb, with all its amazing technology, can resolve the surface of 3I Atlas's nucleus. We are too far away, the nucleus is too small, and the laws of optics are relentless. When will we finally be able to see the fine details of objects like this? Ray has an answer, but it will require patience, a lot of patience.
The answer resided in the future of terrestrial astronomy. In various places around the world, international consortiums were building a new generation of telescopes that promised to revolutionize our observational capability. The most impressive of these projects was the extremely large telescope, currently under construction in the Atacama Desert in Chile. With a primary mirror 30 meters in diameter, this instrument would have unprecedented resolving power for a ground-based observatory. Combined with adaptive optic systems that compensate for distortions caused by Earth's atmosphere, the extremely large telescope could potentially resolve details in solar system objects that currently appear as simple points of light. But there was a temporal problem. The telescope would not be operational until approximately the year 2032, 7 years in the future. By then, 3I Atlas would be billions of kilometers away, having completed its encounter with Jupiter and continued its journey toward the depths of interstellar space. The window of opportunity to study this object with current tools was limited, and each passing day represented a lost opportunity that would never return. This reality added urgency to observation efforts. Each captured image, each recorded spectrum, each brightness measurement taken represented data that would be analyzed for decades by future scientists. Ray understood that his work, however modest it might seem, compared to the great institutional projects, was part of this collective documentation effort. Comet 3I Atlas was a messenger from another time and another place. It had formed approximately 4,600,000,000 years ago, when the universe was younger, and the stars of the Milky Way were just beginning to develop their own planetary systems. The materials composing its nucleus had been forged in the hearts of stars that exploded as supernovas, had floated for millions of years in the molecular clouds of interstellar space, and finally had condensed into a disk of gas and dust, orbiting a newborn star somewhere far away in the galaxy.
Think about this for a moment, dear listeners. The atoms that formed that comet were cooked in the heart of stars that no longer exist, stars that were born, lived their cosmic lives, and died in cataclysmic explosions before our own sun even began to form. And now those same atoms are passing through our neighborhood, greeting us briefly before continuing their eternal journey. Doesn't it seem to you that there is something almost spiritual in that idea?
The chemical composition of 3I Atlas was a direct window into the conditions that existed in that other primordial solar system. The spectra that scientists were collecting contained information about what elements and compounds were present in what proportions, and how they were combined. This information could be compared with what we know about the composition of comets born in our own system, revealing similarities and differences that would illuminate our understanding of how planetary systems form in general. The anomalies that Ray had identified, the brightness increase 400 times greater than expected, the spectral jump from red to blue without passing through green, were precisely the kind of clues that scientists needed to begin unraveling the chemical history of this object. Each deviation from normal represented a question waiting to be answered, and each answer potentially opened new lines of research. Did 3I Atlas contain complex organic compounds, the precursor molecules of life as we know it? Was there evidence of thermal or radioactive processing in its history, indicating that it had passed near other stars on its long journey? Was its structure solid and homogeneous, or did it show layers of different compositions accumulated over eons? All these questions were on the table, and the answers were literally passing before our eyes. Ray's frustration was understandable from this perspective. Every detail omitted in official communication was a lost opportunity to capture the public's imagination and generate support for astronomical research. Every minimized data point was a fragment of the story that went untold to millions of people who could have marveled at it. It was not about accusing NASA or other agencies of bad faith. Scientific institutions face multiple and sometimes contradictory pressures. They must communicate their findings in a way that is accessible to non-specialized audiences. They must avoid generating unnecessary alarm about objects that, however impressive they may be, pose no threat to Earth. They must balance the excitement of discovery with the prudence of the scientific method. And they must do all this while competing for attention in a media landscape saturated with stimuli.
You know, my friends, I don't believe there is a conspiracy to hide information about the comet from us, but I do believe that something is lost when science is filtered too much before reaching the public. Something of the original wonder, of the pure awe before the mystery of the universe. Ray is reminding us that this awe is still available to anyone who wants to seek it, even from their backyard. Doesn't it seem to you that this is something beautiful?
As the days passed and Comet 3I Atlas continued its trajectory toward Jupiter, the worldwide astronomical community remained alert. The great observatories scheduled observation sessions, orbital satellites adjusted their instruments, and thousands of amateurs like Ray pointed their telescopes at the night sky whenever conditions permitted. It was a truly global effort, a demonstration of what humanity could achieve when multiple observers worked toward a common goal. From the deserts of Chile to the mountains of Hawaii, from professional observatories to suburban backyards, Earth's eyes were fixed on this visitor from the stars. Ray continued to publish his observations regularly, accompanying them with detailed analyses and comparisons with data from other sources. His audience grew as more people discovered his work, attracted by the combination of technical rigor and communicative passion that characterized his presentations. He was not the only amateur astrophotographer following the comet, but he had managed to establish himself as a respected voice in the community. His criticisms of NASA's official communication also resonated with a broader audience that had experienced similar frustrations in other contexts. The tension between institutional experts and informed citizens was a recurring theme in the information age, and the case of 3I Atlas had become a tangible example of this dynamic. What made Ray's criticism especially effective was that it did not come from a place of antagonism or distrust. He was not suggesting that NASA was lying or manipulating data. He was simply pointing out that certain elements of the story had been underestimated, that certain data deserved greater prominence, and that the public had a right to the complete picture. It was constructive criticism, backed by verifiable evidence, and presented with appropriate respect for genuine scientific work.
And here we arrive at a point that seems fundamental to me, dear listeners. What responsibility do we, as the public, have to seek information on our own? Should we settle for what official press conferences give us, or should we be more curious, more demanding, more active in our search for knowledge? Ray shows us that anyone with enough dedication can contribute to science. Wouldn't it be beautiful if more people followed his example?
Thus ended, for now, the terrestrial chapter of the story of 3I Atlas. The comet would continue its trajectory toward Jupiter, would face the tidal forces of the gas giant, and eventually would emerge to continue its journey toward infinity. Scientists would continue analyzing the data, publishing their findings, debating their interpretations, and somewhere in the world, under a sky that still hid unsolved mysteries, amateurs like Ray would continue pointing their telescopes upward, searching for the next surprise that the cosmos had prepared for whoever took the time to look. The universe was vast, ancient, and for the most part unknown, but each observation, each data point, each image captured by instruments large and small added one more grain to our collective understanding of that vast mystery. 3I Atlas had been a spectacular reminder of how much remained to be discovered, and that the discoverers did not always wear lab coats or work at famous institutions. Sometimes the discovery waited patiently in someone's backyard, visible to whoever had the eyes to see it and the heart to marvel.
This was the story of the comet that came from another sun, of the astrophotographer who revealed what space agencies preferred to minimize, and of all of us who for a moment lifted our gaze from our daily concerns to contemplate something infinitely larger than ourselves. If you enjoyed this journey through the stars, I invite you to subscribe to our channel. There are many more stories waiting to be told, and I would love for you to listen to them with me. Until the next cosmic adventure, friends, may the stars illuminate your nights.